We're going to be looking at an overview of conics, and there are three major conics we're going to explore. First of all, what is a conic? A conic is simply the idea of how a plane intersects with a cone. And we're going to look at examples here. But the three major types of conics that we're going to explore are ellipses. And the key with ellipses is you're going to have an x squared term plus a y squared term. And notice this includes circles. Ellipses, you may think of them like ovals, but circles are also included in that category. We're going to look at parabolas, which you're also familiar with. And notice they are something like y equals x squared or x equals y squared. There's only one term that's squared. And then last but not least, we're going to look at hyperbolas, which are often described as looking like two parabolas. And in those, you're going to have an x squared minus y squared term or y squared minus x squared. So those are the key components to look for algebraically. Notice the description here based on the intersection of a plane with a cone. The ellipse comes from the intersection of this plane with one half of the cone. And this is what an ellipse looks like, the projection down. The parabola comes from the plane intersecting parallel to the line that goes through the vertex, but does not include the vertex of the cone, that is. And then the hyperbola is when that plane intersects both parts of the cone. We are going to look also algebraically at what these look like. And I just talked to you earlier about how to look for that x squared plus y squared for an ellipse, x squared minus y squared for a hyperbola, and just one of the terms being squared for a parabola. We in particular are going to let b be 0 for all of these. So we are just going to be looking at this algebraic function. And then what we're going to do is we are going to look at what's called the standard form. Again, the key things to look for are if this term is positive, if one of these terms disappears, then we know it's going to be a parabola of some sort. And then the last thing I want to do is look at the geometric definition. For an ellipse, we have these two special points called foci. Notice they are not actually on the ellipse, but by definition, an ellipse is the set of points for which the sum of the distance of the two foci is equal. So this point right here, if I add up D1 and D2, is going to be the same distance as if I put another point over here and added up D1 plus D2. So it's not that D1 and D2 are equal, it's that the sum of those points is the same. If you consider it for a circle, remember, it's kind of like the radius is always equal distance from the center. For a parabola, geometrically, we define it as the set of points where the directrix and a point not on the line distance are equal. So this focus, again, not on the parabola, and then a directrix, which is that line that is running opposite the foci, these distances are equal. And last but not least, the hyperbola, the distance D1 minus D2, the absolute value of that is going to be a constant. We're going to look at each of these individually. And the first one we're going to look at in our next video is the idea of an ellipse.